Welcome to Lesson 8, example number 3. And we have these two 24-inch times 24-inch square columns. And one's right here. This is one column coming in. And here's your other column coming in. And it's not 100% clear what exactly our dimensions are, but I'm assuming this 20-foot dimension between the two piles. We also know this 2-foot dimension from the center line of pile A to the property line, so we know that this is a fixed distance. This isn't going anywhere. And then we want to figure out what's the width and the length of this footing. And if those assumptions change, I will let you know later. Anyways, it also lets us know that the column A, so this is column A right here, it's coming in at dead load is 120 kips and live load is 80 kips, and our column B has a dead load of 180 kips and a live load of 120 kips. It also lets us know that the entire footing, despite what we say size we say it's going to be, they say, hey, the footing weight is 40 kips and our allowable bearing pressure is 4 kips per square foot. Let us go ahead and get started. The first thing you want to do is you want to figure out the center of this, excuse me, the center of the footing. You want it to balance out from these. So let me think. Just on the top of my head, you think of it like a what is that? A teeter-totter, I guess. It's just one of those moments. You want to equalize the moments to make sure that this thing's not it has one side with more pressure on the other, because then you're going to have a situation where you'll be like this, and you'll have more pressure over here, and you might end up having settlement issues, which probably wouldn't be the end of the world, but what they want you to do is go ahead and I'm going to get a little bit stronger on my eraser tool here. There we go. But what they want you to do is equalize, or have the center be where the resultant is. Alright, so I guess it's more easy to describe by just doing the math, and you can see where it comes from. So let's first go ahead and add these up. So you have what? You have 200 kips total load, and you have 300 kips total load. And then you can effectually take the moments about A, or I guess you could do it the moments about A or the moments about B. Also, you know that this footing weight, it's going to be equal about wherever the center line is, so it's going to it won't be included in this moment. I hope that makes sense to you. So the most intuitive way I can tell you what I'm looking for here is you want it to have this type of loading. You don't want this side to be more heavily loaded, and I kind of mentioned a teeter-totter. But we'll go ahead and do that. I'll write a quick equation to kind of show you what I'm doing. So we have let's call this PA, or PB, since it's over there. And we have PA. And PA is 200. And PB is 300. So I guess at what point, I think they call the fulcrum, let's think about it, just off the top of your head, intuitive wise, which side is the fulcrum going to be on? Let's say this is half. Which side would the fulcrum be on? It's always force times distance, so if you have the same distance and you have a higher force, then this one's going to control, so it'll start to go down. So we want to move the fulcrum this way, and you'll see that, so this force times this distance equals this force times that distance. And I hope that makes sense. But you can remember, we can write this a quick equation. Let's just do that, because this is what I would do. There's other ways you can do it, and I think they do it a different way in the study guide, but I guess when I just look at that equation, I don't know exactly where it comes from. Actually, I wouldn't know exactly where it comes from. I do know where it comes from, but just looking at it and not doing engineering ever, I wouldn't know where it comes from. So this is what I would do, is take a step back and think about it. Just say, okay, well, I want to balance these. How would I do that? So you figure out a fulcrum, and I think I've drawn a little bit too much. I'm going to clear this up real quick. Okay. And again, we said the fulcrum is going to be on this side. What else do we know? Let's see, what color should we use here? Let's go to green. I don't see any green. Okay. This distance, this entire distance, is 20 foot. And then let's call this distance, let's make the longer distance. Let's call it, let's not use A, X. And then this will be 20 foot minus X. Alright, I hope that makes sense. Because if you have 20 foot, okay, let's say this is, I don't want to use the answer, I'll use 14. So this is 14 foot. 20 minus X over here, this would be 6 foot. And that makes sense. Alright, so we want to write an equation for this, and we're going to say that, I guess you could say PB times 20 minus X, which is also 300K, 20 foot minus X foot, equals 200K X. And once again, you can get rid of these, the units, because that'll just make it a little bit easier. I know when I'm always used to be doing this, I try to get away from the units as much as possible. I don't think that made sense, but the fact is that K might confuse you, that foot might confuse you. They're just numbers. So 300 times 20, let's distribute this out. 6,000. So I'm getting rid of the units. We know that my answer is going to be in foot. 6,000 minus 300x equals 200x. Alright, and then we need to, let's just go ahead and subtract, well, let's add 300x to each side, and then plus 300x. Probably didn't need to write that out, but I'm showing my algebra. 500x, and let's show the algebra again. Divide this by 500, divide this by 500. X equals what? 60 divided by 5. 12, so that should be 1200. Let me do the math. Yes, 1200. X equals 12, I said 1200. Let's do this again. 6,000 divided by 500, I forgot a couple zeros, equals 12. And we said that answer is going to be in foot. Now let's go up here and do a quick dummy check. Does that make sense? 12 foot, 8 foot. Yeah, that about makes sense, but how can we check that? Well, let's take X and throw it back in here. 300 times 8 foot, and then and that's 2,400. 200 times 12 foot equals 2,400. Okay, we're good. That is our answer. We want the center line. Let's change colors. Actually, I like the green. Let's go with green. The center line is going to be 12 foot away from A. So it'll be a little bit off center. It'll be right here. The center line of the, what is this thing called? The footing. Alright. So this is 12 foot. And remember, we wanted this to be the center of the footing. So if we have 12 foot and 2 foot, then that's 14 foot. So we have to go 14 foot this way. And I guess by definition, 14 foot. Since we want it to be the center, this also will need to be 14 foot. Alright, now you have a 28 foot wide footing. Now we need to find what is this width of the footing. Okay, what is the width? Let's call it W, big W. Alright, then let's scoot on down here. And I'm going to go with an orangish color. And we need to figure out what's our total, since we're trying to figure out what is our width. of our footing, which is based on bearing pressure of the soil. Allowable bearing pressure, we know we have 4,000 KSF. So let's just, hopefully you know this by now. I'm just going to write it. So we know we have 4 KSF is our allowable, equals, remember our P over A is our axial type of pressure, which P we know, so let me get rid of that. P is going to be what? 200 plus 300 plus 40 is 540. 540 kips. Now we need to figure out our area. And area equals length times width, and we already know our length, and width we define as W. And our length is 28 foot times W feet. And we just go ahead and solve for W. And this W is going to be the min W that we need. So let's solve for W min. And if you can think about that once again, I always try to explain this, is you have 540 kips. So if you divide that by more, it's going to be less than this. If you divide that by exactly, then that will get you 4 exactly, which you can't go over 4. So you can, if you get this bigger, you can go under 4. All right, I won't explain that anymore. I'm betting you understand this. All right, W goes over there, 540 divided by 4 divided by 28. You get 4.82. 4.82 what? Ah, here we go. I have foot. I have kips square foot, so we have foot. So, being me, I'm going to round this up to 5 foot. Let's see what they did. And they did the exact same thing in the example. So this will be your answer. Oh, sorry. Actually, a more accurate answer was, what size combined footing should be used? What size combined footing should be used? And I would say a 28 foot 0, excuse me, by 5 foot 0 footing. And that is your answer. I will see you on the next video.